Wednesday, next Wednesday. So you're going to write, this will let me, you're going to write exam Wednesday. So starting out our arithmetic series is we are going to do a definition, and that is going to be the definition of a series. So definition, series is going to be the sum of terms of a sequence. The sum of terms of a sequence. So what does sum mean?
Answer to addition.
Addition. So you're going to be adding up all the terms in a sequence. You have another definition. And it's going to be a finite series. Is going to be the sum of a term where you have a first term, so has a first and a last term. So it has a first and a last term. Then you're going to have an infinite series. And that is where you have a first term, but your series goes on and on forever. So has a first term, but no end. So from our notes yesterday, can anyone give me an example of an arithmetic sequence? It's just numbers. It's like number, comma, number, comma, number.
3, 6, 9, 12.
Yeah, 3, 6, 9, 12. So we're going to write here finite sequence. Looks like this: 3, 6, 12, 15. Let's go on to 18. Well, if we have a finite series and we are adding, we're finding the sum of the terms of a sequence, then we are adding all of these things together. An infinite sequence we've also talked about. We just didn't call it that. An infinite sequence is whenever you have some numbers like 3, 7, 11, 15, and so on, but you have these little ellipses. And you'll have an infinite series where you have 3 plus 7 plus 11 plus 15 and so on. So keep in mind, you're going to have those little ellipses there. We have 2 more definitions. And that is going to be of an arithmetic series. Which is going to be the sum of the terms of an arithmetic sequence. Makes sense, right? So an arithmetic series is the sum of terms of an arithmetic sequence. Lastly, this guy is super important. It is the sum of a finite arithmetic series. And this is a formula. This formula is read S sub n is equal to n over 2 times a sub 1 plus a sub n. Can anyone tell me what n means? What does n represent from our pop quiz yesterday? Yeah, it's the number or place in line. So number or place in line, the number of the term. What is a sub 1, someone else?
Starting point.
Yeah, it's the starting point. It's our initial condition. And what is a sub n, someone else? Yeah, the name of a sequence. Thank you. So name of a sequence. So n is the number or place in line. A sub 1 is the initial condition. A sub n is the name of the sequence. So let's do an example. Our example is going to ask us the question, what is the sum of the even integers from 2 to 100? And for those of you that are still writing, I'm going to put this example up here at the top. So our question is, what is the sum of the even integers from 2 to 100? So again, what does sum mean? Adding. What is an integer?
How far is there a number is from 0?
So that's actually absolute value. So that's making it harder. But can you give me an example of an integer? 1, 2, 3. Isn't -1, -2, -3 also examples? So they're whole numbers that can be positive or negative. So whole numbers. So we're looking for the sum of even integers or whole numbers from 2 to 100. These instructions are telling you that this is a series and we're trying to find the sum of a series. So let's think about this for a second. Let's rewrite this from 2 to 100. Let's rewrite this as if it was a series. So we would have 2. What would be the next term in line? So we're doing even integers. 4. The next one.
6.
And then we would keep going until we got to 100. Is this a finite series or an infinite series?
Or no,
It'll be a finite because we do have some end. So we're looking at 2 plus 4 plus 6 plus 100. Now, what I want you to do whenever you're approaching problems like this is I want you to go ahead and write down the sum of a finite arithmetic series and figure out which variables you can identify, which ones you don't have yet, and see what you need to find. So the sum of a finite series was S sub n is equal to what? Mm-hmm. Mm-hmm. A sub 1 plus what? A sub n. Very good. So we just said that we are looking for some sort of n. We're looking for some sort of a sub 1. And we're looking for some sort of a sub n. So if we're looking at this series, can we identify anything? A sub 1, what's a sub 1? 2. Now the things that we don't know is we don't know how many terms are in the series. Okay. We don't know how many there are. I mean, we know this is going to be the first term, this is going to be the second term, this is going to be the third term, or this is going to be a sub 1, this is going to be a sub 2, it's going to be a sub 3, and so on. But we don't know what this guy is. So I just kind of gave it away, but what other term do you think we can identify here? Well, yeah, we have 2 and 3, but we're trying to look for n, a sub 1, and a sub n. Yeah, so we have a sub n, which is going to be 100. Whenever you can't find an n, whenever you can't figure out what your n is going to be, I want you to write an explicit formula. So let's do this. So if you can't find n, make an explicit formula. So can someone find the formula, the explicit formula for an arithmetic sequence in their notes?
A sub n
Mhm.
equals a sub 1
Mhm.
plus n minus 1 times 3.
Very good. So let's see what we can find. Bills, do I know what a sub n is?
Yes.
Yes, what is that? 100. Nathaniel, do I know what a sub 1 is? What is it? 2. Ethan, do I know what n is? No, we don't know that because we can't find n, right? Can't find it. And then we have D. What is D? Does anyone remember what the name of that is? What that represents?
Constant.
Yeah, it's the difference. It's the difference. It's the common difference. All right. Remember whenever we did our sequences yesterday or the day before where we added D each time? Yeah, so our common difference, D, is going to be 2. So I'm going to put a 2 right here. So let's see if we can solve this. So I've got 100 is equal to, help me out, Josh. What do I need to write?
Two
Mhm.
plus some, or parentheses A minus 1, parentheses times 2, but
Yeah, what do we do with that too?
um,
What is it distributed?
2 and n minus
2n minus 2.
2, and we combine that terms.
Yeah, and so then you combine like terms. So you have what, 2 and negative 2? So you have 100 is equal to
2,
2n.
and you divide each side by 2.
Yeah, then you divide each side by 2. So n is equal to what?
50.
Well, we just found it. Wow. Aren't those all the components that we need for our sum of a finite arithmetic series?
Yes.
Yes. So let's fill it in. I'm going to copy down again. S sub n is equal to n over 2 times a sub 1 plus a sub n. And let's figure out what all I can substitute. If my n is going to be 50, what do you think my s sub n is going to be? S sub what? Yeah, it's going to be s sub 50. Well, and I would actually prefer that you all write it like this, right underneath it, so you can maybe see it more directly. My n, again, was equal to 50, so I'm going to substitute that there. What was my a sub 1, Haley?
2.
2. And what is my a sub n, Emma? Goes now? 100. This we can solve. We've got 50 divided by 2, so that'll be 25. And then we're multiplying that by 102. So what's our answer there, Josh, since you've got it?
2,550.
Yep, that's what I got. 2550. So what does that mean? What does 2550 mean? Yeah, that's our sum. That's the sum of our finite series. So I have one that I want to put up here, and I want you to try and do it. It should be easier. I want you to try and find the sum of this series, where you are given the series 4 plus 9 plus 14 plus blah, 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 plus 203 plus 207. So take a second, try and identify what terms you can. Use your formula. And see if you can find n, a sub 1, and a sub n. What is a sub 1, Nathaniel? 4? That's our starting term. Emma Price, do you think, can we identify any of these other ones? Do we know what n is, or do we know what a sub n is? Yeah, what's a sub n? Yeah, 207. So we know those two guys. Do we know what n is? Do we know how many terms we have in this sequence, in this series? I'm sorry. No, I don't know what that is. So what do I do to find that?
Use explicit.
Yeah, so let's try and create an explicit formula. So what is my explicit formula for an arithmetic sequence? Jesse? Very good. Very good. So my a sub n was 207. My a sub 1 was 4. Do I know what my n is? No. So I'm going to put that there. And what is my D? 5? So we're going through here and we're adding 5 each time?
Wouldn't that be 208 then?
No.
Because 203 plus 5 would be 208.
Oh my God, please don't hate me. I looked at the one below it. This is supposed to be 99. Oh my God, please don't hate me. Ah, I thought it looked weird.
Oh, no, beautiful.
Shout out to you, Josh. I'm so sorry. It's Friday. Leave me alone. I gave you guys extra credit at the beginning of class. What's really bad is sometimes I'll be like in the middle of third block and I'll be like, wait, have I told you guys this? And they're like, yes. I'm like, okay, I can't remember. I've said it 3 times today. Okay, please don't hate me. Can you guys solve this on your own? Yeah. Solve that guy for N. Feels, what do you want to do first? So on the last guy, we distributed this 5 out, right? So let's copy down that 99. Let's copy down that 4. And we're going to have plus what? 5 times N is? And 5 times -1 is? 5 times -1. Yeah, very good. All right, Elijah, what do you want to do next? Yeah, you can combine those like terms. So 4 minus 5 is going to be what, Elijah? -1s. We'll have 5n minus 1. Now help me solve this, Haley.
You're gonna add the 1 to the 99.
Mm-hmm.
And you're gonna get 100. Then you divide that by 5 and you get 20 for n.
So 20 is equal to n. Cool. We finally got n. So with that in mind, whenever I'm going through and I'm filling in the sum of a finite arithmetic series, I'm going to have S sub what? What do you think? S sub 20. S sub 20 is equal to what? I have n over 2, so 20 over 2. Then I have times a sub 1, which is going to be 4, plus a sub n, which is going to be 99. So 20 divided by 2 is 10. And we multiply that by 103. What's 103 times 10?
1030.
Ta-da!
Add a 0 to n.
Yeah. Yep. Not too bad, right?
No.
It's kind of, I really like this chapter because it builds on itself really well. I think it's like really intuitive. Okay. So now we're going to get into the fun stuff. We are going to be writing a series in summation notation. And I love me some summation notation. This was the stuff that I loved in college. So writing a series in summation notation. You'll see this if you go to college. You'll see this in like your first algebra classes and things like that. Like this will be used everywhere, and then it'll disappear off the face of the earth until you get into like, I would say probably upper level calculus. So it's going to be really heavy at the beginning, and then it's going to disappear, and then it'll come back. So if you do like chemistry or something like that, it'll rebound. So let's, I'm not going to put that. I'm going to do this guy. Have we seen this guy before? It's okay if you have not. Kind of looks like a M. This guy is called a Riemann's sum. A Riemann sum. So if you're asked to put something, write this as a Riemann sum, that's what that is. Riemann sum. You're going to have a final or your last term here. So that'll be your A sub n, your starting or your first term. And then what you're going to write here is, usually you'll have some parentheses, sometimes you won't, is you'll have some sort of formula, usually an explicit formula that we've already come up with. So the really nice thing about this chapter is that we've already been doing this part over and over and over again. We've been creating formulas for the past like 4 sections. So we've got that down. So it's really not bad trying to build on top of that. So let's say that we've got this example. Let's say that we are asked to write this series in summation notation. That's where the 203 and the 207 came from. I'm so sorry. So let's see what all we can figure out. We know that we're going to have to create some sort of formula for our Riemann sum. So what is the explicit formula for an arithmetic sequence? Ooh, we're forgetting one thing. A sub 1
Plus n minus 1.
plus n minus 1. Let me see. What items do we know? Do we know A sub n? That's going to be 207. Very good. Do we know A sub 1?
Yeah.
7. Do we know what n is?
No.
Nope. Do we know what d is?
+4.
We're adding 4 each time. So I'm going to take each of these parts and I'm going to substitute. I'm going to say 207 is equal to 7 plus, I don't know what my n is, so n minus 1. And then I'm multiplying that by my d, which is 4. Try and solve that on your own paper. Make sure that you distribute it, right? So your 4 is going to go there, and there. So that one's right. I'll try the second one. What is n equal to, anybody? N is equal to 51. So you're going to do arithmetic. So you find that n is equal to 51. So what you're going to do is you're going to take that n is equal to 51 and you are going to put that here. So this is the last term. It's the 51st place. This is number 51 in the sequence. And so if that's our last term, and this is our starting term, then that's number 1. So we're going to put n this time, even though this is also technically n is equal to. Down here for proper summation notation, you're going to put n is equal to 1. And that means that we're starting at the first place in line. There are going to be examples where it's like, hey, n is going to be equal to 3, and that means that you're starting over here. But in general, for most of the examples that we're doing, you're going to have n is equal to 1 right there. So lastly, it looks like we're trying to find a formula. So you're going to come back and you're going to say a sub n is equal to a sub 1 plus n minus 1. If I gave myself enough room. Times d. And we find our formulas by just substituting the things that we know on this right-hand side. So 7 plus, what did we find n to be? Okay. Let me backtrack for 1 second. So we did find n to be 51, but whenever we have an explicit formula, we always have one variable that's left over. So what is that? So I'm actually going to leave my n as it is in order to create a formula where we always have that secret ingredient. We always have something we don't quite know. And we do have my d is 4. So if we simplify that, I'm going to have 7 plus 4n minus 4 or 4n plus 3. Because it uses an n, that is what I can put in here. So 4n plus 3. You see how we found that? No. For our last example, we are going to find the sum of the series. And so what happens whenever you're given the summation notation? So what is the sum? And you're given this example that has your summation notation. It has a 70 and it has n is equal to 1. Your formula is 5n plus 3. I do not want you to be daunted by these because these actually, once you get the hang of them, are very fast and very easy. Let's talk about our sum of a finite arithmetic series. We have S sub n is equal to n over 2 times a sub 1 plus a sub n. To find the sum of this series, we need to find these 3 items. A sub 1, if a sub n is equal to 5n plus 3, a sub 1, you remember whenever we replaced our n's with whatever number we put in that subscript? So my a sub 1 is going to be 8. So I'm going to write a sub 1 is equal to 8. Your n is going to be the number of terms in your series that you're trying to add up. So you're trying to add up 70 terms total. So your n is going to be 70. If my n is 70 and I'm trying to find some a sub n, and I replace that n with that 70, then what is a sub 70? Mm-hmm. Yes, 5 times 7 is 35, so 5 times 70 is 350 plus 3. So wherever I see an n, I am going to replace it with a 70. So s sub 70 is equal to, I've got 70 divided by 2 times a sub 1 plus a sub 70. What was my a sub 1?
80.
So I have 80. What was my a sub 70? Whee. What is my a sub 70?
353.
And this is just something that you put into your calculator? So what's 35 times 361? And that is the correct answer.